Section 2.2 Tangents from an external point. You can see the circle with two tangents, and we have 2 points of contact, P and Q. So the two tangents are orange and yellow in color. So these two tangents are only touching the circle, so that's why they are tangents. And we are going to look at these two tangents that come from an external point. The external point is not on the circle. So the external point is our point T, which is very far away from the circle. So we are going to look at some properties of the tangents from an external point. So here we have the two tangents, TP and TQ, from the external point T, and these two tangents touch the circle at P and Q respectively. So what we know is that these two triangles, triangle POT and triangle QOT, are congruent because of RHS. Now I'm not going to go into the details of the proof of these two congruent triangles, but since these two triangles are congruent, we know that from the two corresponding sides, TP equals TQ. Second, again using corresponding, this time will be angles, the two corresponding angles of the two congruent triangles. Angle POT, which is the angle at the center, is equal to angle QOT. So these two angles at the center are equal. And the third property would be angle PTO is equal to angle QTO. So the two angles at the external point are equal. And the reason for this would be tangent properties. So if you use any of these three, you don't have to use all of them together. You can use any one of them, and you can use the reason, tangent properties. So let's look at example 2.6. In the figure, AB and AC are tangents to the circle at B and C respectively. So let's try to make use of the tangent properties. Right now, I don't have the angle at the center, and but then I do have these two lines, AC and AB. So from the first sentence, we know that AC equals AB because of tangent properties. So we'll make use of that later. And we also know that AC is produced to D. So AC is made longer to point D such that BC equals DC, which already has been marked in the figure. We are also given angle CBD is 32 degrees. So if angle CBD is 32 degrees, we can consider this triangle BCD, and this angle must also be 32 degrees. Angle D must be 32 degrees. And we need to find angle CAB. CAB, I mark this in red. So we are going to start with triangle BCD. Because I have more information, at least I have one of the angles, which is 32 degrees. Next, we will make use of exterior angle of triangle to find angle ACB, which is 64 degrees. So this angle here is 64 degrees. So I guess if AC equals AB, which is our next step, then this angle should also be 64 degrees. Angle ABC should be 64 degrees. So lastly, we can use angle sum of triangle to find the angle we want.